unit.
So we really already finished up the solutions portion of the chapter. We're going to move slightly today into what we call the colligative properties section. So it sounds kind of complicated, but it's really not. A colligative property is just something that is affected by the concentration of a solution. Okay? So we'll use the concentration calculations to determine the colligative properties. We'll learn what those are in a few days. But first today, and we'll skip this chart. These are constants that we'll use in a couple of days at spring break. So first, let's think back to the good old double replacement reactions from last December. So double replacement reactions are the reaction between two aqueous ionic solutions that result in the production of what? An aqueous solution plus a solid, or a liquid, or a gas, typically a solid. So an example of that would be NaCl AQ plus AgNO3 AQ yields AgCl solid. How did I know that was a solid? Where did I look? At the solubility table. Okay. Plus NaNO3 AQ.
Wait, what is silver nitrate?
What do you mean, what is it?
Like aqueous.
Yeah, it's two solutions. So then I would balance it, but it's already balanced. We're in good shape there. But we learned the first day of this chapter that when ionic solids are dissolved in water, they do what? They dissociate. So if we look back, most ionic compounds dissociate when dissolved in water. So sodium chloride does what? It breaks into Na plus Cl. So does NaCl AQ really exist stuck together like that? No. Does AgNO3 AQ exist stuck together like that? Does AgCl exist stuck together like that? Yes, because it's a solid, it's not dissolved, it doesn't dissociate. NaNO3 breaks apart. So we're going to write what we call the Ionic Equation. So an Ionic Equation is going to show the individual what? Ions. So when sodium chloride dissociates in water, what two things do I get? Na plus AQ plus Cl minus AQ plus Ag AQ plus nitrate yields AgCl solid plus sodium AQ plus again nitrate. So all I did was everything that was aqueous, I just dissociated it. I actually showed on the paper what was truly happening. So when sodium chloride dissolves in an aqueous solution, the sodium and chlorine break apart. I get Na plus Cl minus. Then for silver nitrate, I get Ag plus NO3 minus. Silver chloride does not dissociate because it's not dissolved. It's just a solid. Yeah.
So what's the difference between sodium nitrate as an aqueous solution and then having sodium?
This just shows what's actually happening. So what's a more accurate representation of what actually happens in the solution? This one or the Ionic Equation? The Ionic Equation actually shows me what's happening, right? But what is the actual product of this reaction? The AgCl solid. That's what I'm making. Okay. So for the net Ionic Equation, I want to condense down the Ionic Equation and only show what's important. Okay. I'm only going to show what pieces are important to make the solid product. So what's my solid product? AgCl. What do I need to make AgCl? Ag plus. Do I need the sodium or the nitrate? No. Those ions I don't need. Then it's already balanced, so I'm in good shape there. So that's what I call the net Ionic Equation. That is just the ions that I need to make my solid product. Okay. So now If you go to a sports game and you're a spectator, what do? Do you actually participate? No. So these spectator ions, are they participating? No. So what ions are not participating here? Na and nitrate. Okay, so those are what I call my spectator ions. They are not participating in the net ionic equation. Okay, are they still present though? Yes, but they're not participating in the chemical reaction. Okay. After spring break, we'll talk about some examples where I need to know what ions are still in solution. Okay. If I have a 100% perfect reaction, will I have any Ag plus or Cl minus left over? No, it's all going to be made in AgCl, right? Then I would just have these two ions left over in solution. Make sense? So it looks like a lot, but it's not. You just break these apart, write the ionic expression, the net ionic expression, you cross out basically what you don't need to make the solid product. Then what we don't need to make the solid product, we call these spectator ions. They're just extras. Okay? And we'll use these spectator ions for calculations in the future because these are the ions actually in solution. Okay? Questions about that? So let's look really quickly. This chart at the bottom, it just asks us for a couple of different compounds to write the dissociation or ionization reaction when you dissolve it in water. Tell me if it dissociated or ionized, then we'll talk about the last column in a second. So, what type of compounds dissociate when they dissolve in water? Ionic. So, I have here, I have Na plus Cl minus. That's what solid sodium chloride looks like. Na plus beside Cl minus just beside each other. Okay? So, when they break apart, do I have to form the ions? Or are they already formed? They're already formed, just breaking them apart, just dissociating them. Okay. So what type of molecule ionizes? Acids. Okay. So hydrochloric acid, that's what it looks like. Does it already contain ions? No. So when I turn it into this, I had to make the ions, right? I had to go from the covalent bond to the ions. What do I call the process of making ions? Ionization, okay. So acids ionize. Ionic compounds dissociate when they just get dissolved in water, okay. Let's look at one together. Silver chlorate. The first step is figuring out what silver chlorate is. What's the formula for silver chlorate? Nope. AgCl03. Some of y'all don't know your polyatomic ions. Okay, so it breaks apart, it dissociates into Ag plus Aq plus ClO3 minus Aq. Did it dissociate or did it ionize? It dissociated. It already had ions, they just broke apart. So now, the last column says if we dissolve 1 mole of silver chlorate, how many moles of ions do I get? So 1 silver chlorate molecule makes how many ions? 2. Okay. So AgCl03 breaks apart into Ag plus and ClO3 minus. Okay. So if I have 1 mole of silver chlorates, how many moles of ions do I get? 2. I get 1 mole of silver ions plus 1 mole of chlorate ions. Okay? Does that make sense?
Yes,
Good.
sir.
Look at the next one. First, the issue hopefully isn't, but it might be, what is sodium acetate? Most of y'all got that one. So break it apart. Na plus Aq plus C2 H3 O2 minus Aq. I ran a little tight on space there. Did it ionize or did it dissociate? Dissociated. How many moles of ions did I produce? 2. And no, the number's not always going to be 2. We'll see an example where it is in just a second. Pretty straightforward, right? So look at the next one, hydrochloric acid. What is the formula for hydrochloric acid? HCl. When HCl is added to water, does it dissociate or ionize? It ionizes. It's an acid. I have to make the ions. So I get H plus AQ plus Cl minus AQ. How many moles of ions did I produce there? 2. Question so far? Go ahead and try the next one. Potassium carbonate.
Wait, so when you have the acid, it doesn't affect the numbers.
Just look at how many pieces you have for that.
Oh,
Okay, so potassium carbonate is K2CO3 solid. You get 2K plus AQ plus CO3 negative 2 AQ. Did it ionize or dissociate? Dissociated. How many moles of products did I get? How many ions? 3. 2 potassiums, 1 carbonate. So it's not the number of unique ions, it's the total number of ions. 2 potassiums, 1 carbonate. Okay? Yeah. I don't, sorry. Okay? Go ahead and try the next 2. Lead 2 nitrate, sulfuric acid. So you can check yours online when you get done. So all I'm doing is writing the reaction for either the ionization or dissociation that happens when you dissolve one of these things in water.
is that good?
Yeah. So it goes to the liquid. I'd say what's going to taste worse, the tap water or the distilled water?
It's not like
I
brown.
want to taste the distilled water.
I tasted it, it's not that bad.
It's not going to taste terrible to you, it's just not the most pleasant water you'll ever drink.
But it's the best water for distilled, right? It doesn't have any chemicals.
Well, define best, it's the purest, but best is kind of a, yeah.
No, but
I thought hydrogen was diatomic.
Hey guys, good question. The diatomic rules do not apply to ions, okay? Or when they're dissolved, they only apply when it's in the gas form, yeah.
there's a water thing down the hall.
You can go fill it up? No, I'm kidding. I'll go in just a second. If I left, I would come back and the camera would be missing. It would be unplugged and gone.
Miss, okay. Your videos can hear you talking about your emotions. I remember the time you showed us like
That way they get the full experience.
little model thingy, and it was still going. I'm like, they're like, what are you talking about?
Alright guys, so any questions about this? We'll skip the last few. So now turn over to the back. So look up at the top. It gives us 3 reactions. Ammonium sulfide solution and cobalt 2 nitrate solution. If they're mixed, what kind of reaction is it? Double replacement. So the overall reaction just wants you to write the double replacement reaction. Predict the product, write S or AQ, and balance it. The net ionic equation wants you to show, the normal ionic equation, wants you to show the ions. So if ammonium sulfide is soluble, you're going to write NH4 plus and S negative 2. Okay, show it breaking apart. Then the net ionic equation, you're going to show just the ions responsible for producing the solid product. Okay, it's kind of progression. Just the normal reaction, expand it, showing all the ions, then condense it down to just the ones I need to make the solid product. Okay. Also, circle the spectator ions. So which one of these three places will you have spectator ions? Overall, ionic, or net ionic? Only in the ionic. In the overall, you'll just say ammonium sulfide aqueous. There won't be any ions. Okay. So only in the ionic equation will you have ions present. Okay. Any questions about that? So guys at home, I'll show you the answers really quickly, so you can just pause the video and look at it. Yep. So go ahead and work on those three.